Okay, I sent you home last night was with two major topics I wanted you to talk about. Trying areas of triangles, oh my gosh, this is like not honors pre-calc if it's 90-degree angles, right? Because it's just base times height divided by 2. This would be 6 divided by 2 is 3. Raise your hand if you would understand that. Okay, good. And then the next one is, what if it was not 90 degrees, but this was actually 89 degrees? Now, that's not going to give you the right answer because base times height divided by 2 wouldn't be right anymore because you don't really have the height. All right, so instead, you could use a different formula. Find it right now. If you understood what I was teaching you last night, you know how to do this. So give this one a shot. There's a formula for that, and if you don't have it memorized, he'll tell you. You know what?
Yeah.
What is it?
1/2 AB.
Excellent. Nope, that, what you're thinking of is the law of cosines, and that's totally different. This is the area of any triangle. Now, it's very close to the law of cosines. Just to clarify, the law of cosines is a squared plus b squared equals c squared, but it's got this extra little modifier in there. Who can finish it? Yes? Minus 2ab cosine c. All right, very good. That's different, obviously. This one is also used for non-right triangles, and you can figure out a lot of stuff from it. You can figure out angles, you can figure out sides, you can, if you have angles, but that's different. Right now, what you should be doing is that red formula right there. Is this one set up nicely for 1/2 AB sine C? Yes, it is, because it's got a side angle sandwich. Do you get, if this 3 were over here, it wouldn't work so nicely? Do you get, you have to either figure out this angle then, or you'd have to figure out maybe this side over here. You get what I'm saying? If you knew that side, then you could do heroes. If you have all 3 sides, heroes is awesome. All right, so back to this problem, the way it was originally written, and it is set up nice. That's like your A, that's like your B, and the angle that's between them. Okay, so then you go 1/2. I'll call A the 3, doesn't really matter. B is then going to be the 2, and then it's sine of the angle between them, which is 89 degrees. I'd need a calculator to do that part, but look, it's a lot like 1/2 base times height. It just has a little factor thrown in for that angle not being 90, but being something else. Okay, what'd you get? 2.99? I like it. All right. It can't be 3, though, really. Well, actually, obviously it's not going to be 3, because 3 times 2 is 6, and half of that is 3. It's just saying it's really close to 3, because that's what it would have been if this had been 90. So its bottom line is it's a little less than 90. Does that make sense to you? If the angle's a little less, areas would be a little bit smaller than 90 then? Well, sorry, a little bit smaller than it would have been because it isn't 90? All right. If it had been 90, it would have been exactly 3. All right. Then one more kind. What if you do know all 3 sides? Well, it isn't hard to figure out the third side of this, is it? What is the third side of this? A squared plus b squared equals c squared, right? So you go square root of 3 squared and 4 squared makes 9 and 16. Okay, 3 squared and 2 squared. Sorry, 3 squared is 9, 2 squared is 4, and do I add them or subtract them? Add them. So that's square root of what? 13. Now, if we had to do heroes on this, it'd be a little bit of a pain because you have that square root of 13 to factor into all your calculations. So let's make it nice. Let's do the classic 3, 4, 5 triangle. 3, 4, 5. I know already that the answer is 6. I mean, because it's base times height divided by 2. Okay? But try using heroes, the formula, because heroes would work even if it wasn't a right triangle. You know, I could change this to a 1 or a 2, 4, 5 triangle, and then it wouldn't be a right triangle anymore. It'd look more like this. Okay, well anyway, but back to it. Let's keep it a 3, 4, 5 triangle, because my point is, you'll know if you did it right if you get an answer of 6, because that's what the area really is. So if you don't know how to use heroes, this will show it up. I'll pause for a second while you try using heroes. In case you haven't got the formula, we had it on the topic sheet, but it was wrong. Anybody notice that? Here's what, I'll clarify that right now. That's not D, it's an area. Area for heroes is supposed to be square root of, and this S thing is the semi-perimeter. It's not the average of these sides. That is not what we're doing. Kind of like that, but it's different. The perimeter of this shape, which is this plus this plus this, all three of them added together will make your distance all around, okay? And that'll be 9, 10, 11, 12. But then you cut it in half because it's the semi-perimeter. So semi-perimeter here would be 12 divided by 2 is 6. That is not the average of the sides. It's bigger than that. The average of the sides would be less than 5, for instance. All right, so anyway, it's a semi-perimeter, and we take that, and that wasn't wrong in the sheet, but we missing an S on the sheet. Sorry about that. S minus A, S minus B, and S minus C. That's the formula that should have been on the sheet. Use it right now just to double check for yourself that you get how to use heroes. I see a couple cell phones out on the desks. I don't see you using them right now, but I'd like you to put them away so that I don't have to talk to you about it later when you are tempted to use it. Don't even hide it underneath your iPad in the little crack. I'm not saying, I'm not looking at your crack, but don't hide your phone in there. Put it somewhere else. Okay, so semi-perimeter, we already figured out, added all these up, added a 12, and half of that is 6. So you should have said square root of 6 times 6 minus 5 is 1, 6 minus 4 is 2, and 6 minus 3 is 3. And look at that, it's the square root of 6 times 6, square root of 36, which is 6. And some weaker minds would say plus and minus 6. No, square root of 36 is just 6. Okay, because this little square root symbol implies the positive, what do they call it? The principal square root of 6, which is just a positive number. You only get the positive and negative effect when you are taking the square root of a variable. All right. All right, any questions about heroes? Why is heroes in, why can't you just always do base times height divided by 2? Because it's not always going to be a right triangle. Good. All right. So the next topic we talked about yesterday, and I want to make sure you're good at, is let's say that you have a low spot and a high spot. And the answer from the other day, if it was at -2 at 2 p.m., and it was at 12 feet, I'll use feet, at 8 p.m., the answer for that one was y equals, well, I'm going to work you through this one real quick. The dotted line that runs through the middle is really important. Find that. If you haven't already found that, I'll give you a hint. It's halfway between 12 and -2. That dotted line that runs down the middle tells you two things then. Can you tell me one thing it tells you? The amplitude. Good. Okay. So if this can be divided into two distances, each of them is the amplitude. And the total throw there is between 12 feet and -2, and therefore it's a total of 14 feet, making this a distance of 7 and this a distance of 7. And if that's a distance of 7 from this height of 12, then 12 minus the 7 means this blue line is at a height of 5. All right. Why is that so important? Because that tells you a couple of things. It tells you, first of all, you now know this from finding the dotted line, and that's our amplitude. Cosine of b, I don't know that from it. X minus, do I know how far I was shifted to the right from that? No. But I do know this number. That's one of the harder ones. It's how far up was this shifted. I'll give you a hint. Here's what cosine used to look like. The dotted line used to run right down the middle at 0, and now it's been shifted up from there. The dotted line is higher than it used to be. If it used to be at 0, and now the dotted line's at 5, this has been shifted up 5. Where do you get this number right here from? Yes, sir. The x of the high spot. The first high spot we come to is here. And what's x? The 8 p.m. or the 12 feet? 8 is the time. Time is x. So 8 p.m., the time is your x value. It's an 8 there, not a 12. I get how some of you would have thought from the way I wrote it before, that you thought x was this and y was that. But if you think about it, the height of the water being the high here means that that had to be the 12. All right, anyway, moving on. This b is got two formulas for it. B equals 2 pi over period, or rearranged, period equals 2 pi over b. So either way, we need another period to get the b, right? And that's the period on this guy. Well, you say it took 6 hours to go from here to here, so that's the period. True or false? Yeah, 6 hours is something, but it's halfway completed with its period. It's not done yet. It has to wait till this goes all the way down to another low spot. So you got to double the 6. That gives you a period of 12, and therefore your b is 2 pi over 12, also known as pi over 6. Are there any parts of that you'd like me to talk over more thoroughly? Yes, sir. Why do we double it? Okay. If you have a wave, what I gave you is from here to here. Is that a complete cycle? No. Now, how about if I told you from here to here? Would that be a complete cycle? If it was 2 p.m. here and 12 p.m. there. Yeah, that would be a complete cycle. The way you can tell it's a complete cycle is it's returned back to where it was in the first place. This was at a high spot. It's at to another high spot. That's a full cycle. So in this case, I would not double it. When they only give you from a low spot to a high spot, that's only halfway done. So you have to double it. That make sense? All right. Any other questions about this problem? All right. Then let's move on to other topics. And I want to cover lots of things. One of the things I want to cover in this hour, because I didn't cover it in the other hours, is polar. Let's talk about polar for a little bit. And then I'll let you ask me more questions after that. Because we really haven't talked about polar very much in a long time. This spot right here. Do you agree you can get there by rectangular coordinates, like going over and up? But you could also get there by polar. If so, the polar coordinates are r and then theta. Okay? R is like how far out you're going to go. And then theta is what angle you want to be at to get there. I really wish they gave these as theta then r, because then I could start with knowing the angle I'm shooting out at first. Okay, you're going to go up this way, and then it would just, the r would tell me how far to go that way. All right, so anyway, there's two components. I'm going to draw a little line. This is important that you know. This is not the answer. This is just a little helper line. That's the place we're going. I'll make it a bigger blue dot. That's where we're going. That is what we need. So we need this angle right there. Let's say I told you that that angle was 2 pi. No, it's not 2 pi. It can't be 2 pi. It could be 2 what? 2 pi over 3s. I agree. So that's 2 pi over 3. And let's say that I say it's 5 long. That's the distance here from here to here. You get how that would be 5 comma 2 pi over 3? Okay. So then, what's another way to write that? You can get to that same spot using polar with either bigger angles or negative angles or negative r's or negative r's and negative angles. There's lots of things you can do to get there. So tell me another example, another address that gets you to this same spot but does it in a different way. Yes, sir. Negative, you're going to use a negative angle. Negative what did you say? You are correct. That gets you to the same spot because you go using that black angle the negative route. Whole bunch of pi over 3's and you just count them up and you get to here and you go, oh, I've gone 3 pi over 3. I got to go one more, 4 pi over 3. Okay, good. Got another way?
Yeah, -5,
5 pi over 3? Let me check if you're right. First of all, to get the negative in there, what you're saying is you want them to go to a place that's completely opposite of here, which would be like over here. And then when you say -5, it'll bounce you over to that spot. Okay? So where are we if we're down here? Well, if this was 2 pi over 3 for an angle, then if you just keep going and say, well, then this would be 3 pi over 3, 4 pi over 3, 5 pi over 3 would be our angle to get to that spot. And then the negative will bounce it over there. So you are correct. This will get you to the same exact spot. You'd start here, and then the negative of the 5 would make it go whoop, whoop, over to there. Okay? Yes? All right. -5, negative pi over 3. All right. So that's saying you can get to the same spot and use the negative aspect to bop it over here, but you want to use a different angle, and that's from there to there, which is a negative, and I agree that's -pi over 3. Good. I think that's every possible combo. Oh, what are we missing?
There's 5, 8 pi.
Oh, if you're going to get really big angles, we could have unlimited. And you make a good point, though. 5, 8 pi over 3. And then you can just keep adding 2 pi to it, right? And get bigger and bigger and bigger angles that get you to the same spot. Very good. So that's like, here's where 8 pi over 3 is. This is 6 pi over 3, 7 pi over 3, 8 pi over 3. Ah, it's just going all the way around once. Plus some more. All right. Good. Oh, wait. Back to this other one. This same spot. Remember how I said you could get there with rectangular or you could get there with polar? Well, there's a gajillion ways to get there with polar. Would you please tell me what the rectangular coordinates are then? What I'm really saying is if I had a triangle here, what would this side and this side be? Surprisingly enough, you can use trig for that. I'll be fine with you leaving your answers with like cosine of 2 pi over 3 in it. I'll pause for just a second while you try that one. Okay, so here's how you should have thought about this one. If this is 2 pi over 3, then this is just pi over 3, also known as 60. Now, if that's a 60, then this is a 30, and then this is the 30, 60, 90 triangle. And then I know this is a 1 and a 2 and a square root of 3. But wait, what's wrong with that? That 2 really isn't a 2. In our example, it's a 5. And therefore, if my ratio is supposed to be 1, 2, square root of 3, then I have to somehow make it bigger. Well, would you agree I can multiply by something and make this actually be 5? I can multiply by 2.5, or also known as 5 over 2. If I multiply by 5 over 2, 2 times 5 over 2 would make 5. So I just figured out I can scale it up by multiplying everything by 5 over 2. So I multiply this by 5 over 2, and I multiply that by 5 over 2. So now can you see my answers for x is -5/2, and for y is 5 root 3 over 2. I know that was a little intense. Sometimes you can make the numbers come out a lot nicer than that. Like for instance, if I had made this side just B2 in the first place. So say it was the same problem, except I'll make it over here, and I'll make this side B2, and I'll make this be pi over 3. So my directions are 2, pi over 3. And the question would be, can you make that into rectangular? Yes, sir. Nothing wrong with using a regular trig. Absolutely. Nothing wrong with that. Okay, but would you try this one, please, and tell me what its X and Y are? Should be pretty easy if you understand what's going on here. So this is pi over 3, also known as the 60. Miss M, can you finish it off for me? Can you tell me like how you got stuff? 1, 2, square root 3 triangle. Okay, cool. And why did you know this was 1? Very good, because it's across from the 30. Okay, good. Now what do you do? Well, you already have the rectangular coordinates. And what are they? You got it. 1 comma root 3. Raise your hand if you had that one right. Okay, good. Okay, so that's finding rectangular coordinates from polar. Now, I don't want to be like the one who tells you, here's what you should want to know, because there's a zillion things you want to know. I just don't know which ones you're weak on. So why don't you look on the topic sheet, find something else that would make you nervous if it was that problem right now on the test, and then ask me to talk about that. Easy. Yep. So let's say that I have a sector of a circle. Let's say I am in a boat and I am dragging a couple of water skiers. And so this is the rope going back to the one water skier A, and here's water skier B. And the angle between them is 20 degrees. And let's say I know how long my ropes are because there's a standard rope length for water skiing. Does anybody know what it is by chance? So if there's any pro water skiers who haven't memorized, I'd love to know. All right, I'm going to go with 80 feet. Okay. Then my question is, if we think of this as an arc in between the two people, okay, how long is this arc that is between these two people? I'll pause for a second. Let me give that a try. Okay. First thought, do you know the formula? Memorize it. S equals theta r, SOAR. Does that ring a bell? S is the arc length. Theta is your angle, which is right here, except there's a catch. Has to be in radians. And then you just times by the radius, which we know and is really easy. So the only real challenge is knowing the formula and then remembering that the formula has to use radians. Okay, give that one a shot. I'll pause while you try that. So the question I just got was, how do you change degrees to radians? You can always multiply by a fact. That's just true in math. Is if I multiply by 1 over 1, that's a true thing, right? 1 equals 1. I could say 1 foot is 12 inches. That's a fact too, right? What's a fact you know about radians and degrees? 180 is equal to what? Pi. Are there other facts you could use? Yeah, there are, actually. 2 pi is 360. That you could multiply by that fact if you wanted to. So we're just multiplying by a fact that we know. So if I multiplied by 180 over pi, that's not going to really help very much because I'm going to get degrees over pi. I don't want that. But if I multiply by pi over 180, then a lot of things help because they get canceled things, and then all of a sudden you'll have radians. Okay? All right, so that's how you get your thing changed into radians. Let's just finish it from here then. So Miss T, tell me what you got when you actually did change it to radians. Okay, it's right here. So I like to think about, if you can factor it, you should. That bottom can factor into 20 times 9. Why did I just do that? Because then you can cancel. Cancel the 20s. What is it? Pi over 9. So you put a pi over 9 here. And then, my equals got really wonky there. There we go. Times the radius, which is 80. All right. If you can factor it, you should. Factor the 80. What is it? 9 times 9? 8 times 10. Okay, but then the 9 is 3 and 3, but nothing is going to cancel, so that's not going to work so nice. So we'll just say 80 pi over 9. And at least we know that we can't reduce it. Do you get if we could have reduced it, but the factoring would have done it for us? So, all right. So this, a lot of people get confused. They say, but Mr. Server, I got an angle. That doesn't make sense. Just because it has a pi in it doesn't mean it's an angle. Pi is a number. What is the number? 3.14. So you just take 80 times 3.14 and divide it by 9, and you'll have your answer. And your answer is in feet, because the problem was in feet. So, oh, I had a degree symbol there. That was not good. That was supposed to be a feet symbol. Anyway, so this is in feet. And I don't know exactly what 80 times 3.14 divided by 9 is, but that's how many feet it is. Okay. Question? Go ahead. Okay. All right. So that was a question about sectors and angles. S equals theta r is what we used. You got a topic? It can be about any topic that is on the list of topics. So I'm sure that is, because complex numbers are in there. Okay. So I'll do a quick example of the 3 third roots of, let's go with 1 minus I. There are 3 third roots of that. All right, so if I asked you to find the 3 third roots of this, the first thing you want to do is put it in what form? Cis form. Let's do this quick. The cis form for this, I need a picture to be able to do this, and I know it goes over 1, and I know it goes down on the I scale, the yi scale, goes down -1, and so therefore this little dot is right there, and I now can figure out what angle that's at, and when I'm down here I should use negative angles. Remember that? Okay, so then what's the cis for this guy? It's r cis theta, and the r is, well, how long? It's a 1, 1 root 2, so it's a root 2 cis, what? Negative pi over 4. Very good. Okay, now I got to take that and do the 3 third roots of it. Any questions on the cis form? That again we got by saying this is the angle. The angle there has got to be, well, this angle's 45. Okay, this angle's 45. And I think I drew that triangle funny. Oh, I think about it. I should have drawn the triangle here. Let me see. And I drew that triangle funny. It's still right because it happens to be a 45-degree angle. Sorry about that. It should be 1, 1, and this is -1 technically, and that's a 45-degree angle. But technically it's negative because we're down here, so it's negative. So this would be this distance, square root of 2. Those are always positive. Square root of 2 cis negative pi over 4. And I did draw the picture funny there. Okay, so anyway, you're doing the 3 third roots. Here is the third root. So you probably don't know what root 2 to the 1/3 power is. I don't. One thing you could simplify that to is, do you get that root 2 could be written as 2 to the 1/2, which is then put to the 1/3? Do you get it's really 2 to the 1/6 power then? All right. Anyway, that cis, and I wish I could just do one of these and be done. The 1/3 has to drop down not only onto this, but also in front of that. And so I'd have 1/3 times negative pi over 4, and I'd be done. But that's only one of the third roots. I need to have a little generator that'll get me all 3 of them. So, who remembers the little thing we got to throw in here that's going to generate more terms? plus 2 pi n, and that goes in here. And now, remember that this 1/3 is going to hit both parts. And then, I don't want to have to do this the whole way out because it takes forever. N equals 0, n equals 1, and n equals 2 will give me 3 answers. And I wanted 3 third roots. So I stick 0 in. This whole blue part at the end just cancels out. It's gone. So then I just have to do 1/3 times negative pi over 4 makes negative pi over 12. For the next one, I'm going to stick into this area. I'm going to stick in an n equals 1. And then it'll be a 2 pi. Then it'll be 1/3 times negative pi over 4 plus 2 pi. A lot of adding. It'll take a long time, but that's the process anyways. That's how much I'm willing to devote to this. Yes? Next topic? Or any questions, follow-up questions on this same topic? Yes? Yes. So how much did you, once you figure out the next one, and let's say that it went up 6 pi over 12, then you can keep adding 6 pi over 12. Especially handy if you've got to find like 5/5 roots. Once you figure out the pattern of how much the angle went up, you can just keep going up that same amount each time. That's true. All right, who's got another topic? Yes? Bearings. Ooh, good. We haven't talked about that yet. Now, one of the things that's good about having multiple classes is kids ask different questions. So what I'm doing is recording the video in each hour, and it's different in each hour. Like nobody asked me about bearings till now. So that's a topic that if they're in a different hour, they're going to watch this video. Same for you. They ask questions in the other hour you didn't ask. So you can go and watch my, well, obviously you don't want to watch the same hour you were in. So you guys are in my 4th hour, right? So you could watch the 3rd or the 2nd hour videos and you could see other questions that were asked. So you might be able to do more review that way if you want. That's just a resource for those that want that. All right, so let's talk about bearing. Let's say that the person, let's do the little compass rose things. Let's say that the person walked at a bearing, a true bearing of 45 degrees. And they walked from encampment A to they made a camp at B, okay? They walked for 5 miles to get from camp A to camp B. Then they walked at a true bearing of 100 degrees. This was true 45. And at this spot, they went true 100 or 100t. And they walked 7 miles. No, let's make it 3 miles at 100. They went 5 miles this way. And they went 2 miles to get to encampment C. Did I say 2 or 3? Just what do you guys have? 2 or 3 mostly? Mostly people have 2, so I'm going with 2. All right, I think I said 2, but you could easily rewind it and find out. But I'm sticking with 2 now. So then the question could be, how many miles will it be for him to get back to Camp A? Main thing I'd like you to do is to try to draw the triangle. Try to remember the formulas that help you find things like this. Okay, if you don't know what true 45 means, that means 0 degrees is like here. So true 45 means like this. Okay, that means a 45-degree angle this way, which of course in this case with 45 happens to mean it's also 45 from there, but true means always you're starting straight up. Okay, then I'm going to move this compass rose just a smidge to match it up with that better. Then from there they went true 100 degrees. Well, here's where true 90 would have been. We always start with 0 there. So true 90 would have been there. So it's just an extra 10 degrees more past that. So they're going to go like that, where this would be a 45-degree angle because that was a 45-degree angle down here. And this is going to be a 10-degree angle, which makes that a how many degree angle? An 80-degree angle. Awesome. And then that makes this an 80 plus a 45-degree angle. All right, so this angle right here is 125. And then my last side, I'll make it green here. I said, how long is this? I didn't say how long it was. This was 5. This red one was 2 miles. And you can figure out this one. Who's got a formula that would probably help? What do you think? Law of sines. Law of sines is especially good if you have an angle and the side across from it. Do we have that situation? We have a 45-degree angle here, and we got the side across from it as a 2. Yeah, so law of sines. No, you don't think so? Oh, that's not a 45. You're right. 45 would be all the way down to here. Sorry about that. Okay. So maybe we don't have an angle and the side across from it. What do you think, sir? All right, let's use law of cosines because you don't have to have that whole angle on the side across from it thing. All right, so law of cosines. A squared plus B squared minus 2AB sine, or cosine, law of cosines, cosine C equals C squared. All right, we do know this angle that's across from the side we don't know. Another way to write this formula, by the way, is if I want to get C alone, do you get I'm going to have to take the square root of it? And therefore I can say the square root of this whole thing is equal to C. And I know cosine of C, that angle, the big angle C, in this case, that angle is this angle, and therefore that is 125. And I know A and B are 5 and 2. 5 goes here, 2 goes there. I'm going to pick A as 5. It doesn't matter. You could swap those and it'd be no problem. This is a 5, and this is a 2. So help me make sure I don't screw this up. 25 plus 4 minus 2 times 5 times 2. Cosine of 125. What is cosine of 125? Somebody with a fast calculator. Cosine of 125. Go ahead. It's okay that it's negative because we have a minus here, and it'll be all right. And that's in radians. Oh, negative 0.57 is in degrees? Okay, good. And this is equal to our answer. So now we need somebody to multiply. I can do 25 plus 4, and that's 29. 29 minus the negative, those will cancel. We're going to add 29 plus 10 times 2 is 20, times about a half is about 10. So it's about square root of 39-ish. And it ends up being, what is that about? All right. And what did we just figure out? That side. Which is 6.36. Awesome. And of course, using trig, we could find out other angles in here if we wanted to. But be careful, this is not a right triangle, so that makes it complicated. Whenever it's not a right triangle, we should probably use law of cosines, so we could go back and figure out an angle if we wanted to using law of cosines. Okay, and you can also just kind of deduce angles by looking at the relationships between these things. Like that angle there will be equal to that angle right there, for instance. And this, anyway. Whew, stuff gets intense. I have time to do another concept. You have another one? Question on the last one. Go ahead.
So where's the, so when at B, where does the
Okay. So we were at B was this compass rose, right? Okay, and you start at 0. So if I had said to go 0 degrees once you get to B, I would have been saying go straight up because that's 0. If I'd say from there go 90 degrees, you would have gone straight that way. Get how that would be 90? It's like your angle starts here. If I said 100, or if I said 0, go there. If I said 90, go here. If I'd have said go 180, you'd have gone straight south. But I said to go 100, which was a little more than 90, so there. It does bring up a good point. What if I had said go 80 degrees north, 5 degrees south? No, that's not right. Go north, 5 degrees, let me think. North, 5 degrees west. Make a compass rose, show where you think that is. North, 5 degrees west. Well, here's north, so you kind of get close with that first one. And then 5 degrees west means from there, split off 5 or more degrees towards the west. So that's the direction I was saying to go. Does that make sense to you? No, that's east. Sorry. Got my east and west mixed up. That's east. This is west. Sorry. So it would have been 5 degrees towards the west, where that's 5 degrees. Raise your hand if you had that one right. Okay, good. And let's say I had said west, 10 degrees south. Make a little compass rose, show where you think that is. Here's west. 10 degrees south of that would be about, that's too much. About there. Raise your hand if you had that one right. Okay, good. I think you get bearing then. Yes?
What form did you get it?
You get a sheet full. In fact, if you take a look, you won't be scared sheetless on this test. You will have a sheet. Everybody look at the Schoology page, and you will find a sheet that it says you get to have. That one has a whole bunch of formulas on it that you'll be able to use on the test. Okay, next topic. Who wants to know something else? Yes?
Can we do a problem trig identity?
Trig identities, sure. I've got one for you to see if you can prove this one. Ready? Oh, wait a minute. What are you? Is it on the list of topics for second semester? Okay, I'm pretty sure trig got all. It wasn't pretty much all the trig in this semester.
Yeah.
I think it was. Okay, so here we go. Cosine squared over cosine squared plus 1 minus cosine squared over cosine squared should be equal to secant squared. Prove it. Now remember, when you're proving, in general, what I've found is you take the complicated side and you manipulate it, and you have to leave the other side alone. You can't manipulate both sides in a proof. You can manipulate either the left side and make it turn into the right, or manipulate the right side and make it turn into the left. I'm fine with either approach. The way I've got my answer set up, I'm going to manipulate the left side and show you how it turns into the right side. All right, we don't have, to be honest, we don't have time right now for all of you to get this answer, but let's just try to think of like little leaps. Who sees something we could do? Mr. JG. These could turn into a 1. You're absolutely right. And I'll do that. 1 plus, and who's got something else we could do? What do you think?
So 1 minus cosine squared becomes sine squared.
That is the same exact thing as sine squared. Awesome. And so that's sine squared over cosine squared. And now I got to leave this alone, so I'm just bringing that straight down. Ooh, we're close. Yes? And this is the same as tangent squared. Why do we care? Because now because 1 plus tan equals, well, we're supposed to get secant, and this is secant. And how would you end the proof? Secant, no, just secant squared equals secant squared. This right side has to have stayed the same the whole way, and so therefore you needed to come out to the same thing on both sides, and that is equal to that. So you can make that swap. Okay, good. That's an example of a, they can obviously be tougher when the teacher doesn't tell you what to do, and might have taken you 10 minutes to get that one, but. All right, now your homework for tonight. Pay attention while I show you this. Your homework for tonight is a worksheet, which is posted with today's date on it, 6/2. And I'm going to pause while I show you. Okay, you'll see it on the screen here. It says review homework assigned on 6/2. When you open it, you will find that it is about 8 questions long, and that would be too much because these are hard. I do want you to do the first and second problems of it. Now, this is important. The answers are at the end of the same file. If you immediately go from, don't know what to do, I'll look at the answers, you won't remember it nearly as well as if you work at it for a bit before you go look at the answers. Some teachers did not post the answers at all for this. And the reason I decided to leave the answers there is because I'm trusting you to do the ideal, which is work at it for a while, struggle with it, try to do it as if you didn't have the answers. If you are totally stumped after, I'd say, about 10 minutes, then I would go look and see, and that'll, honestly, it'll stick so much better when you really understand what the problem is before you go look and see the solution to it, okay? So get problems 1 and 2 done of that worksheet, just 2 problems, okay? And then the answers are in the back, so you can be done with that. Then the assignment for tomorrow in class is going to be to do the other, I think there's 6 more problems on there that you're going to do in class with a partner, and by the end of the hour, double check your answers, okay? So there will be more homework assigned, which the teacher will tell you what to do for the rest of the homework. But that's what you're going to do in class tomorrow. I'm going to be gone tomorrow. I have a doctor's appointment I have to go to. Yes, so I'll see you on Monday. That's all I have for the video for today.